Hainan University. Monaco is watching you and listening to you. Your microphone seems to be on. Now it's off. Hainan University, thanks for the video. We can't hear you, we can't listen to you. Try to talk, microphone seems to be on. The program of the Tech Talk today: Hainan, Capgemini Engineering, Ensta Paris, RIT Dubai, Uniboat, Sunflare and Tenderworks. Does your microphone works? Yes. You're the main speaker and we are listening to you. I think it's good. We can listen to you. Try to talk, please.
Can you hear from us?
Yes, we are listening to you. You have 7 minutes.
Great. Okay, it's our honor to present our boat here. First of all, I would like to introduce the team members from us. Professor, the team lead of our team lead, and senior lecturer Cui from School of Telecommunication. It's our pleasure to meet us today. We also have a few students from the team as well. This is our research team here. Okay, next I will briefly introduce our boat. Can you see our slides? So the first is our design principle. Our goal is to design a green environmental protection boat. So we try to use and utilize existing technologies to manufacture a green energy boat. So we are going to briefly introduce from 3 sections: overall design, the energy, and the sea test. Sure. Okay, just hold on a second. So this is our design principle. So our goal is to design a green, environmental friendly boat and utilizing existing technologies to manufacture a green energy boat. So today we are going to introduce from three sections: the overall design, the energy that we are using, and the sea test. So this is the overall design of our boat. So as you can see, we have a hybrid power supply that has a battery built in, and we also have a cap cage, a steering engine, and a beam. So this is the whole design. We have a carbon plate loading beam design, and we have few pipe clamps. This is a waterproof seat that can control the boat. We have also the steering wheel, an action bar, and footrest. We also have a shock module installed to absorb the shocking. This is our design framework. It's the power management system. So we have DC converter. We have 3 kilowatts battery that can provide a maximum 100 amp. The boat is also capable of equipped saltwater battery, solar panels, but we didn't equip them today as today's sea trial. We also have a DC to DC power management system. And this is the flow chart of the power management system that we built. And this is the power management system energy flow diagram. So we have a solar seawater battery that connects to a DC to DC converter, and then which connect to the battery module and provide the power for the boat. This is converter design and general power management system block diagram. This is general design, the circuit diagram that control the boat. So this is the picture from our today's sea trial. Few more pictures. It's a lovely dog. These short videos we captured today during our sea trial. Okay, thanks for listening. This is our brief introduction. Hopefully, give some ideas of our boat. Thanks very much.
Applause, applause for Hainan University. Thanks a lot, Hainan University. Now, jury members, you have any question? Mr. Jérémy Lagarigue, jury chairman.
Yes, thank you very much for your presentation and congratulations for the job done so far, because for a first trial without having seen and participate in the previous tech talks, you made a very good job. Could you please give us a bit more details about the battery technology, because it looked like it was a sea salt water technology batteries, and I think that might interest a lot of people, if it's what I understand correctly.
Okay, thanks. 这样介绍这个盐水电池是吧？可以把盐水电池问一下盐水电池具体怎么做的？这个我们不是做这个化学专业的，我们是做电子专业的，所以这个盐水电池呢是中国科学大连化工所王乐总教授提供的。So the sea water battery is provided by our partner from Chinese Academic of Science, Dalian Chemical Research Institute. So we are actually use their technology. So they provide the sea salt battery. If you want more details, we can provide after the meeting. We don't have much technical details about battery itself.
I think
that will connect to that battery.
Yeah, if it's what I think it is about, yes, for sure, we are all very interested by having the results. Can you just give us maybe the size and the weight and the amount of energy you are able to store in the battery?
The battery, hopefully next year when we participate the event, we can bring a seawater battery, sea salt water battery that I can show during the event.
I'm sorry, I did not understand the answer. Could you try to repeat, please?
Oh yeah, can you repeat the questions again? I didn't hear the questions clearly.
Yeah, my question was, could you provide us the size, the weight, and the amount of energy that you have in the battery, please?
Okay, just focus size. 这是那个电池的大小。哦。40厘米。Okay, just give us a second. 就那个高度呢？ The size of the battery that we're using on the boat at the moment is 40 centimeters by 60 centimeters by 40 centimeters. It's a slow 3 kilowatt battery that provides between 20 volts to 50 volts direct current, and it can provide maximum 100 amp. It's a lithium battery.
Okay, thank you very much. And I don't know if the jury have other question or someone in the room. And maybe we can change the way. So do you have a question on some information that you want to receive from the other team?
你还有别的那个队伍是吗？今年参赛的队伍有什么去年我们是看到了这个氢能，氢能这个参赛。那么今年有没有这个别的除了氢能之外的更新的这个能源的形式？这个就是新能源的形式参赛。Oh, last year when we saw some information about the event, we saw some teams that are using chemical batteries like H2 batteries. So in this year, is there any other teams that are using different type of batteries, like chemical batteries?
Okay, we will try to provide you those information, and thank you very much and congratulations for what you have done so far, and looking forward to invite you in Monaco, or maybe to have a new event of the Monaco Energy Boat Challenge in Hainan, for example, in China. Thank you.
Applause for them.
Thanks very much.
And thanks a lot for the video you sent us before the presentation. Now, the tech talks with another team, a French team, please. Capgemini Engineering. This is energy class. And this is about electric hydrogen with fuel cells and flexible solar panel. Please respect the speaker. Respect the speaker and make silence in the room, please, in the main room, in the exhibition part. Thanks a lot. You can, no, it's better if you keep it. And you have your microphone. Do you have something to move the slides?
It's okay.
If you can move the slides, please. Yes. Thanks a lot.
Okay. Good afternoon, everyone, dear members of the jury, people visiting the event and competitors. I'm really glad to expose our work in this wonderful place. So thank you for being here.
Please, can you respect the people which are doing the tech talks, and also for the exhibitors and the people that go on the bar? If it's too noisy, we will close the bar as we did yesterday. So please be respectful all together. Thank you.
Thank you. So I'm representing the Capgemini Engineering Group. So we are a team that we worked on the CFD part, the design, the hydrogen part, and the engineering. So as for the integration of the technology of the fuel cell, that was our main part. And so just a little presentation of our place where we live. So we are the land of the diversity, multiculturalism, etc. But on Marseille and Aix-en-Provence, we would like to really push the innovation into an energy part, and we like the bouillabaisse and the calypso. Just for what is the part? So the team, we are 10 people, about 10 people, with consultants in the company. Sorry. With 4 trainees, really motivated trainees, and 2 electrical experts. Our system is composed with 4 kilowatt electric motors, a Torqeedo, a 3 kilowatt hydrogen fuel cell from H2C with DC-DC for the convection of the tension, battery lithium ion, so with 2 batteries with 1 kilowatt hours each. We have 3 solar panels with MPPTs and a lot of sensors, because our goal is to really master the system, master all the parameters, and enhance our efficiency. That is the key for for the mastering of the fuel cell, in particular for the temperature. We use the Mux Lab, that is an electrical controller that we develop in our company. So this is an ECU that is used in the automotive industry to have a prototype project, and on which we can add all the sensors and on the intelligence, the algorithm of our system. So we work with Frog Design, that is a company integrated in the Capgemini engineering group for the design. We used aluminum, tubular aluminum chassis in order to be lighter as possible. And it let us master the temperature because we can redirect the flow of the fluid into the right place. So we worked on the CFD parts. So this is an animation, but I can't click on that. So the system is modeling with the Simscape suite with MathWorks industries that sponsor our team. So we have a full model for the physical modelization of our entire system for all the electrical and thermal parts. So as I said, we used CFD for the characterization of the thermal and the aerodynamics simulations. And the strategy is to keep the fuel cell in the right range of power in order to have the maximum efficiency. And for this supervision of the efficiency of the fuel cell, we developed a digital twin. I can speak later on that. So for the materials, we start from 0 6 months ago, because our expertise is more so integration for the client and not the development of a real system in our agency. So all the production was on site. We use a Mux Lab, as I said, for the system algorithm, and we have a tablet. We have a tablet on which we can send the data on the distant servers that we use for the digital twin. The tubular aluminum is made with Baumier, and we have a raw material for the cover that is offered by Sage Ferrari for the design exterior. So we have a 40 kilos chassis aluminum, an ergonomic cockpit for the pilot is really well sit on the into the cockpit. A good thermal management because of the form of the chassis and the fluid that is really free to flow into the chassis. And so we have a first life cycle and assessment. This is really a base that we want to improve for the next years. For the eco-design part, this is for the really first part where we have a tubular aluminum and recyclable materials, but for the next year we would like to have eco-design chassis, eco-responsible. So the digital twin is a platform on which we can send the sensors, the release data, issues from the sensors, and on which we can add physical data, physical models that can enhance and add information like virtual sensors, and have data where we cannot have really real sensors on the different parts. And so we can improve the efficiency really in direct, so in live on the system, at distance and on board. So again is due to the digital twin for the really fine-tuning of the system, but also with the thermal management that is really a good effort on our system with the form of the chassis, the design of the fluid flow, and the thermal management. I think I'm out of time. Thank you very much.
Applause for Capgemini Engineering. Applause, and please now be quiet in the exhibition part of the room.
Do we have some question from some competitors maybe? And other members? In fact, I do have one question. When I see your boat selling later, I say I am a bit interested by having the amount of energy that you can provide some of the solar cells to, because you say we developed this platform in order to receive the data. We are the second day of this event, so you might already receive some feedback from the boat. And my second question is, if you need to already anticipate the next year participation, what would you change the most, and what will be the next evolution plan?
So for the first weekend, for the solar panels, we have about between 200 and 300 watts for the solar panels. I think we have a good efficiency because of the fluid is on and under the solar panels. And what we can change, in fact, we want to manage the center of gravity of the boat, so we can change the position of the chassis. We did that on the event, but also for the eco-responsibility on this prototype. As a first step, we do not do as much effort as we maybe can do on the chassis. In particular, the choice of the different technology for the batteries. It's a lithium-ion, not really interesting for this kind of stuff. And yes, eco-responsibility, and with a chassis with no aluminium, but a new material, for instance.
Okay, and would you change the amount of energy on the engine, because this is a 4 kilowatt engine? Do you imagine that you might have for the next year a 10 kilowatt engine on such a boat?
Yes, 10 kilowatts. I think this is a good power for this kind of system. We choose the 4 kilowatt motors because of the mass of the system. We are already 2070 kilos. We cannot do more. But with a new design, maybe a lighter chassis. That's a problem for the hydrogen. We have a fuel cell with a great amount of mass, and a 10 kilowatt motor is at about 60 kilos. But maybe we can do better on the motor and develop our own system. That's another kind of perspective for the next years.
Perfect.
Maybe just in terms of the overall temperature management, it seems like the space you have and the spacing is really helping out. We have a lot of teams that are using cooling systems and stuff. I'm wondering if you simulated a little bit of the volume you had and the volume you could have had if it was shrunk. What would have been the consequences on the efficiency of the battery, on the temperature overall, of course? But did you get a sense of that when you designed this chassis? Because it seems very interesting to first, in order to cool things, you first need to have a right airflow, you need to have a right design to make temperature manageable before thinking about a cooling system right away. So interesting in that matter.
Okay. For the dimension, the size, the form of the chassis, we have a pluridisciplinary study to lead, and in 6 months it's really hard. But for the dimension, we have also the surface for the solar panel. We would have to have the 2.5 square meters really exploited. And for the thermal management, yes, we maybe can reduce the space. On the CFD part, we have a great amount of aerodynamics inside the prototype, and we count on the thermal, the air-cooled system. The ventilation is the flow due to the advance of the boat, but also because the fuel cell is aspirating the air. And this enhances the thermal regulation. We have the box just in front of the fuel cell, so we have a great forced flow on the box and on all the electrical and electronic parts.
Yes, I think that might be one of the most interesting parts for all the other students and teams that want to participate with the fuel cell in the future to optimize the pressure of the inlet and optimize the outlet of the fuel cell. That's very, thank you for sharing this information, because this is very key for the next event next year. Thank you so much.
Thank you.
Thanks, Capgemini Engineering. And now another tech talk with Ensta Paris. The yellow trousers. Yeah. It's still energy class, and let's talk about your project with electric and custom electric thruster. You have 7 minutes before the questions of jury members. C'est mieux si vous l'adressez à la glace, à la petite fenêtre là-bas. Ça fonctionnera mieux, captera mieux.
So, good afternoon, everyone. We are very glad to be here, thanks to the Yacht Club of Monaco, to present to you our project. So, we are the team Caïman, sent by the Ensta Paris. This is the first time that our school sends a team in this challenge, and not the last, I think. Ensta Paris belongs to the Institut Polytechnique de Paris, with Télécom Paris, Télécom Sud Paris, l'ENSAE, et nous, du coup, and us, so. And we are from Paris. This project began in September with a team that were very motivated to begin the project, and so they began all the conception. However, they could not continue this project because they have to do a stage. So they had to find another team of first year that would be very motivated to be there and to do the challenge. So it's us. And we all were there to concrete what the first team tried to do and tried to do in the conception.
So in terms of ideas and inspirations, the second year students had, they thought of this kind of chassis, and they bought an electric motor, which is from the Maytech, brushless and with the power of 4 kilowatts. We used 2 batteries with a capacity of approximately 0.5 kilowatt hour. One of our specificities, I would say, is the modular aluminum structure, which is reusable for next year if you want to improve our design, which is very eco-friendly. And one of our innovations is our drive-by-wire system, which is not a drive-by-cable system or steering. So also one of the big challenges we decided to make is to start from scratch. Meaning we had to design the steering, the propulsion, not the motor, because this is way beyond our scope, and the batteries, no other batteries. So all is homemade, so to say. And as I said before, everything is easy to disassemble, to improve the design and improve our boats. So we use, of course, 3D experience to design the chassis and the structure.
So the materials we used were aluminum and marine normal plywood, which is waterproof. As we joined the project only in June, we only had 3 weeks to put together all the structure and the motor of our boat. We faced several issues while constructing the boat. First, of course, the lack of time. Then the delays in deliveries, which is a point to improve for the next participations. And a lack of experience in welding and electronics, as we are only first-year students in engineering school. But we'll learn much from this experience, and we will improve for the next edition. Our budget was 4,000 euros, thanks to ENSTA alumni that provide us with this budget. It was quite a very interesting challenge to work on with a tiny budget, because it forced us to be very rigorous on the way we used it. An important point for us was the ecological aspects of our project. So we decided to put together an easily disassemblable structure in order to be able to use all the products, all the raw materials for next year. But still, our boat has an impact on the environment because the batteries still are a bit harmful for the ecology, and we couldn't reduce the impact of our transport from Paris to Monaco and back on a van. But we still decided to use marine plywood and aluminum, which are less harmful than carbon, for instance. And I talk about the modular structure, which is easily disassemblable and reassemblable later.
One of our main innovations we took and we made for this boat is our drive-by-wire system. So, as said before, the steering and the propulsion is we build it ourselves with the help of our teachers who are there and who we thank very much for it. So basically, you have a wheel which is connected to a potentiometer who then measures the angle. This signal is then transferred to the back of the boat, to the motor, who then makes the boat turn to the left or turn to the right. So it is lighter, it has less components, and is less polluting because it doesn't use any grease or oil as in mechanical structures. So to conclude, I would thank a lot the Monaco Yacht Club because they helped us a lot through this competition. We did 3 tests and yesterday, 2 days ago, and we failed, and we did a technical test yesterday, and we concluded it successfully, thanks to them. So thank you very much, also to the organization.
Applause for you.
Thank you, ladies and gentlemen. So I don't know if someone in the jury have a question or in the room.
Good afternoon. I have one question. Why the use of plywood?
Why the use of plywood? I would say that the second-year students thought about something else, but because we began this project properly in June, we faced a lack of time, and then we used plywood because it was the most accessible material we could get in a short period of time. We used the thinnest we could, so to be the lightest we can, and maybe we will use something else next year to make it even lighter.
My question is, why not the use of plywood?
No, and I'm sorry, I am obliged to ask you the question, but last year or 2 years ago, your team was a winner, I guess, about the...
No, it was Estaca.
Okay. And but you already have a boat, no? It was not?
No. We began this year. So
Okay,
we
understood.
began this year.
Understood. And so still, I understood that you were very thinking about your innovation by this drive.
By wire, yes.
Yeah, by wire. That was
Yeah.
not that successful.
Yes.
And
of
could
course.
you share a bit where you are and what might be your future plan about that?
Of course. So, as you could see, our boat remained on land today. The cause of this was that one of the servo motor stayed too long into the water because it failed one of the tests 2 days ago, and at that moment the circuits burned a little, so we didn't have any steering left. So next year I think we'll try to do to use either another servo motor with more waterproof, EP68, or we'll try to do to build a box around so that there is no water around. But of course, this is a challenge to do all this with electronics and not with a mechanical.
Okay, so 2 points. One, I think with some of the team here also in the jury, and we can help you to repair this and fix this with a very simple way, so you will be able to sail tomorrow.
Okay.
That's the first point. And the second one is I'm very looking forward if you can share, maybe, I don't know if you have the details about your engine, because you have a very, very light engine.
Yes.
Which is a 4 kilowatt engine. And all the other team have to learn about your engine because they have a 4 kilowatt engine, which is 10 to 20 kilos heavier than your engine. So that's why the tech talks are very important, because you have to share the ideas. And in a way, you made something very complex from the drive of your boat. But you can repair it and fix it in 5 minutes with just few ropes. And you can just go on the water. So that's the thing that in some time doing some innovation is very good, and that's why we need to share. But as an engineer, we need always to keep the foot on the floor to do something simple. And the most important is doing something simple. This is the hardest. And
yes.
and I think, yes, we all have the same view, but and we definitely have to help you going back on the water tomorrow.
Yeah.
And please share the details of your engine to the other new team, because they deserve to know that they can have a lighter boat with a bigger engine.
Yes, this is also why we make the choice to assemble the motor and the propulsion ourselves, because it was way lighter than the Torpedo, for example, who is used for bigger boats and not very adapted to this boat. So of course we will share and come to our stand, and also I think on the USB stick it is so we can talk with us.
Thank you, congratulations, and before I fly back, I help you to repair your boat.
Thank you very much.
You.
Applause for Insta Paris. They weren't on the water this morning, but this afternoon it was the case in front of the solarium. I call on the stage RIT Dubai. Please, applause for them. Sailing Tigers. It's your turn. Have microphone.
Change the slides.
Energy class. And you have 7 minutes to talk about electric, thermoelectric generator and solar, if you want to.
Hello, everyone. We are so glad to be here today in Monaco Energy and Solar Boat Challenge.
Please, make silence in the exhibition part of the main room. Respect the speakers and the jury members, please.
We are the Sailing Tigers from the United Arab Emirates. We come from the institution from the university, RIT Dubai. We are 9 different students from different majors. We come from different majors: electrical, mechanical, industrial, and we come from one of the world's leading tech-oriented universities. We are so glad to be here today representing UAE and representing the team as the first team from United Arab Emirates and the whole Middle East region and North Africa. So we got the inspiration from the Volkswagen race car that was in 1980. Our propulsion characteristic, the boat characteristics, are the lightweight, cockpit, as well as the thin panel. We have the high velocity, and we have the long battery life, as well as having the no shell.
So as for the mechanical side, we always focus on innovation and to increase the efficiency in any way. So first what we did, we chose a design and we chose all the best components that we could use at that time. And we put everything on AutoCAD before building. Then we started with a structure. We tried to do it lightweight, but at the same time for it to sustain loads. And how we did that is using trusses. We use trusses from the side of the boat and in a way from the bottom to distribute the load and not to have at single points any big load, so there will be no bending or any failure. After that, we know that it's still a competition in a race, and we were calculating the speed at which we can go, and actually we calculated about 24 kilometers per hour, but in the testing phase we got about 22, but today actually in a race, in a drag race, we got almost 24 kilometers per hour, which is improvement and optimization from the testing phase and being here a few days as well. Also, we focused on the energy, so we were calculating how long would it take to deplete the battery that we have at certain power inputs. And also we focused on the acceleration, which is very important for the short races. We also did it with the power inputs and what is the highest speed we can go up to at each power input. As for the materials, we used aluminum for the structure because it's lightweight and it is strong. And we used also a steel beam. The reason for that is our first initial idea of the motor was twice less in weight than we have now. And in the testing phase, we noticed that our plate under the motor bent a little bit. So we had to put a support, a steel beam, which is a very hard support, so nothing happens to the motor when we're in the testing phase. And we also wrapped our boat in a shrink wrap because it's light, it's cheap, and the process is not that complicated. So the problem we faced was we couldn't get the hulls that are used here. So we had to make our own hulls with a similar buoyancy to test in Dubai. And we managed to do that. It was very hard because it was hard to find the material and to make the exact same shape, but in the end of the day we could make it. Yeah, so the material for this house was styrofoam, and inside we had a plate, aluminum plate, which could make a cutout to place the beams. We also have a box where we have a battery and our MPPT, and we had to use the sensors for water and temperature. And we faced a problem of putting the Arduino board inside the box where the water might come.
But at the same time, it's dangerous for the water to go on the electronics, but the sensors had to be there. So that was one of the problems that we faced. And as for the life cycle assessment, we used an app called Sustainable Minds, and we made 2 designs and we compared them. One was with a carbon fiber frame and no solar panels, and the second one was aluminum frame and solar panels, and also the modes of transportation were different. So the 4 factors that were taken in was the manufacturing, the usage, the end of life, and the transportation. And actually the transportation took 14% of the carbon footprint, which for me myself, I found it quite a lot. And now I'll pass to my colleague, Jana, and she'll talk about the electronics.
Hello, everyone. So for the testing and results, we started off with a telemetry system, which consists of sensors to be able to see what's happening in the boat, even when we're offshore. And it consists of temperature and humidity sensors, water leak, just to ensure that there's no water inside the boat. And it was in a controlled environment when we were testing it, because we just wanted to see that the main purpose of it was for it to be fully functional and operational. And then we had our general boat testing. However, we had complications with that because we were only able to test it in water once after production, because due to the current crisis we are in a pandemic, we were not able to easily get sponsorship. However, when we finally did get it, we took it upon ourselves to get all the products that we would need. And yeah, so that as my colleague Dennis mentioned, that the highest speed that we obtained during our first initial and only testing phase was 12 knots, which is approximately 22 kilometers per hour. And over here you see the tables that is from an IoT-based software, or sorry, website, where we would see the data from the sensors while we're offshore. So for the design of our boat, as the industry of renewable energy is currently ever evolving and ever growing in the world, we thought that this would be a good idea to come and join and be part of the competition. And since our boat uses solar energy, which is a source of renewable energy, we believe that it would be a good idea. So to cover the frame of our boat, we used shrink wrap material, and this is a good alternative to other rigid or production-intensive materials, as it decreases energy use during assembly, and it ensures the recyclability of the whole material after we use it. So as my colleague mentioned, due to our geographic location, we were not able to obtain the actual hulls that we would use and we would be provided here in the competition. So we had to replicate it ourselves based on the design that that the yacht club provided for us. And using that, we procured styrofoam material that is from a company that its main aim is for sustainability. So they focus on recycling and reusing materials. So to ensure that there is no unnecessary waste disposal. And finally, our main cockpit is made entirely of aluminum frame, which we used to design a truss system that uses less raw materials while still ensuring that the strength of the boat is there. And this is overall energy conservation. Now I'll pass it on to Isaac to conclude.
Now, as for the two major main concepts of innovation that we had, The first of which is the incorporation of a truss system that allowed us to use much more economically viable aluminum frame, and which was actually much thinner, but offered the same durability as, you can say, a conventional carbon fiber mold or a fiberglass mold. And it also allowed us to use much more less resources as for our frame, which was the heaviest part of our initial design, but now is actually only 18 kilograms. The second concept of innovation was the use of multiple sensors, like the water leakage sensor, temperature and humidity, as well as a gyroscope, which allowed us to keep track of the boat's position, as well as be able to detect any signs of hazard offshore as well. Next slide. And as for the potential for industrialization of the project, we mainly focused on the incorporation of the solar panels and the application of small-scale water transport methods, especially in Dubai, like the water taxi, which majorly is not as efficient as it should be. And our project basically serves as proof of application of those sustainability applications into such water-based transportation methods. More specifically, we looked into the single-driver, eco-friendly method of transport, mainly for leisure activities, which actually would, I believe, be a great concept in the Dubai, especially that it's a tourism attraction spot. As for next slide. And just to conclude, I would like to thank the Yacht Club de Monaco, of course, for their support continuously from the very beginning of us applying to join this competition until today, and of course till the end of the competition, as well as thanking our sponsors like the Dubai Electricity and Water Authority, ePropulsion, which offered us motor equipment, and also C-Zone, who offered us all the marine safety equipment. We have TGAC, who offered us raw material, and of course the Rochester Institute of Technology, who offered us continuous sponsorship and support, both in mentorship and financial support. Thank you very much, and if you have any questions, please pass it on.
Congratulations, guys. Thank you for the presentation. And girls, I bet guys is a unisex thing. Huh? I'm corrected by my neighbor. I think very interested that you guys partnered with another university, Rochester, that we actually know of, very historically involved naval architecture university. So I'm just wondering if that could inspire others to seek maybe more partnership, not necessarily the university you're in, but see if you can actually partner with others to get just other point of views and other experiences. How did, and my question is, how did it come across? How did you come across that partnership? What did it bring to your project? And would you recommend that for other teams to do?
Well, actually, we are the students of RIT Dubai, so our mentor came here in 2019, and he thought it's a very good opportunity to showcase engineering skills, and he signed us up for last year, but we couldn't make it due to COVID, and here we are this year, and yeah, that's it. Would I? Yes, it was his idea. We took this project as a senior design project.
If I may add to it, so as engineering students, it's a 5-year program. However, at the end of our program, we are required to do a capstone project. So when our professor saw that universities were joining here, he thought that it would be a very good way for us to put in our information into actual technical and practical use. So that's when he brought the idea to the university, and then he would choose the students. Yes.
You have to fabricate your own hulls, and did you see any performance difference, and how did you adapt straight away to the new hull and the new design now, in fact?
Sorry, could you repeat, please?
Yes. You have to manufacture your own hull because you were able to have one. How did that, let's say, change your performance, or did you watch any difference with the hull that you have there and the one that you built yourself, in fact? What is the difference between your hulls and the one that you have here, and how do you manage the change?
If I understood the question correctly, is if we built this boat ourselves from the scratch? Or
Yes.
Yes, so... Oh, what is the difference between the house?
Yes. And how do you manage that, the change between the two?
Well, we had the design from the competition, right? So we couldn't afford carbon fiber house, so we're looking for alternatives. And our house that we designed from styrofoam were actually heavier, but once we did the testing phase, it was fine. We could do the testing phase, we could float, and then do the modification.
Thank you. And yes, what you have did is it's very smart, and this is what we all have to learn in the process. You need to have a reference, and following this reference, then you can improve. And by building your own boat and having the test with something very simple, because we did not see a lot of innovation in a way, but because that was the beginning, it is already quite smart, because we have seen that you have made a very good result today, and congratulations for that. So now that you have this reference, what will be the next step? What will be your idea for the future? And if you will not be the one being participating, but I guess and hope your university will come back, what will be your advice to the next generation? What are the main development points where they have to work on?
First, as an RIT university, I think this can be a yearly thing where they go to this competition, because honestly we enjoy, and it's as a fifth-year students, we learned a lot while doing this project. So the theory that we learn is not the same as the practical. And the calculations, all the calculations that we made, actually we were researching, and it's a lot of knowledge to take in. And for the next team, I would recommend to choose a very good center of gravity, because for us, we were a little bit, the center of gravity was a little bit behind, yes, and that could change the results to the better ones.
There is a question.
No, it's, sorry.
Yeah, behind you, Jeremy.
Hello. At the start, I would like to say that was a great presentation. I'm really interested about how are you using the results from the humidity sensors?
So basically, the whole point of the telemetry system is just to ensure that the boat is in a safe condition. Especially since I'm a liaison, I'm the only one in the control center, and I'm basically the middleman of the pilot and the offshore team. So if in the laptop, when we see it on the application online that there might be some type of water inside the boat, I'm gonna inform the pilot so that we can so he would know and maybe stop the boat, and then we'd have to inform the safety team and then inform the offshore team as well.
Okay, so the humidity sensor is used to get to know if the water is inside only?
Yes, it's just for the IP67 box.
Okay.
Yeah.
Thank you.
No worries.
And happy to say that the IP67 rules it is important. Okay, thank you very much. Congratulations.
Thank you so much.
Perfect, thank you.
And applause for you, RIT Rochester Institute of Technology Sailing Tigers. Now this is Italian team. Uniboat, please, with your applause.
Can you hear me?
Jeremy.
Can you hear me okay?
Yeah.
Yes, just a second, please.
You were the winner of today or not?
Yes.
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 Congratulations.
And yesterday. I'm the best.
And yesterday. Tomorrow, no, today morning and on the afternoon as well.
And tomorrow?
As well, morning and afternoon. And on Sunday as well. Okay.
So try to be the best at the Tech Talks.
Yeah. Next one. So we are the Unibo Argonos team from the University of Bologna in Italy. And we are a team made exclusively of students and researchers of the university. And this is the first time that we are presenting a boat in the Energy Challenge. So the University of Bologna itself is in the heart of the Motor Valley, as it's called. So we have ample experience in the automotive racing sector. And as a matter of fact, for example, the university has participated already in other competitions like the Formula Student for more than 10 years now. So we came with the idea of making a boat that resembles a race car. Here down below you can see the layout of our powertrain, which uses a hybrid hydrogen, batteries and solar powertrain, because we believe that this mix of energies is the key for a sustainable mobility. For the propulsion, back. For the propulsion, we have used a commercial e-motor that we have heavily modified from the electronics, the inverter, and also the geometry of the motor, as you can see. And then the energy that goes into the motor comes from a self-built battery pack, a 9-liter hydrogen tank that is used in a 2-kilowatt fuel cell, and everything is complemented with 2.5 square meters of solar panels. Next one. To begin with, to define the design and the sizing of the components that we're using on our boat, we started by building a MATLAB Simulink digital twin of the boat that helped us to understand the behavior of each of the components in the different races. And with that, we have been able to choose the size of the battery pack. Also, this model includes both the propeller and the boat hydrodynamics. So we have been able to model a new propeller that we have 3D printed for the fast races, and also dimension the hydrogen tank that was needed, and especially to simulate the endurance race and develop the energy management controller that we will later explain. That is what we used this morning for the endurance race. Next one. On August 2020, we began production of the boat, and it took us almost 8 months to arrive to the final configuration that you see right now on the paddock. For the production, we have decided to almost exclusively reuse material from other projects, like for example the steel from the cockpit of the race car, and also aluminum from other projects. And this year we are introducing a new eco-friendly carbon fiber application that we will explain later on as well, that we have used mostly for the outer bodywork and the motor anti-ventilation plate and the geometry of the motor. We have faced many problems during this time. First, we didn't know the stresses and the strains given by the waves and the sea motion, so the design of the structure was complicated. Also, for example, we had a broken fuel cell 2 months ago, that was not easy to solve. During the development of the custom inverter, we burned 5 inverters, so it takes time. And also during almost the last testing session, we had some damaged holes, so we had to repair them really quickly, which was not easy, so I think we had enough. Next one. Finally, we were able to test the boat in many testing sessions, first on the lab, then on a lake, which was more or less a controlled environment with no sea, with no waves, and finally 2 other testing sessions on the sea. And we were able to confirm the advantages first of this custom inverter that we have designed. As you can see, we have seen a maximum speed of 14.7 knots, which is 2.5 beyond that seen with the original electronics. And by the way, 14.7 is the velocity that we have done on the speed record right now this afternoon. So verified. But this extra performance led us to another issues, like for example ventilation, that at the beginning we didn't know what it was, so we had to first understand what ventilation was, confirm the issue was ventilation, and then make an engineering analysis of how to solve it. And for example, here you can see the 3 different iterations of anti-ventilation plates and motor geometries that we tested until the last, that is the one that we have on the boat, in which we have been finally able to mitigate ventilation completely.
Good evening, everyone. So for the life cycle assessment, we have performed an assessment of the carbon dioxide emission saving, considering both the boat usage and the boat production. Regarding the boat usage, by means of a comparison between a traditional internal combustion engine with an electric hybrid powertrain, which is the one we have implemented in our boat, we calculated that we are able to save more than 80 grams per kilometer of CO2. Regarding the boat production, thanks to the reuse of materials such as steel and aluminium to build the structure of our boat, and also recycling the carbon fiber to make the motor plate and the other parts of the boat, we are able to save more than 400 kilograms of CO2 emissions. Apart from this, the eco-friendly aspect that I just mentioned, I wanted to focus to a method that we used for recycling the carbon fiber pre-preg scraps. And this method, which is proprietary of a spin-off of the University of Bologna called Carb to Life, gives a second life to the carbon fiber pre-preg scraps, producing a positive CO2 emission balance if compared with newly produced pre-preg. The whole process, starting from the waste material to the final component, has been carried out by our team members in our laboratory. One of the main innovative items of our boat is the algorithm used for the endurance energy management controller. And this controller has 3 targets to handle at the same time, which are the consumption of a certain amount of energy, the maximization of the energy conversion efficiency, and the minimization of the race time. The concept is to associate the state of charge, the global state of charge, to the percentage of the race progress. The global state of charge is the sum of the state of charge of the battery and that equivalent of the hydrogen tank. We carried out the calibration first in simulation environment, and then a final tuning with experimental test. And I would say that this morning the controller has proven to be quite effective. One important thing is that we decided to make the algorithm completely available for download, so it is free from copyright. It's an open source code. And so, if you like, you can just use the QR code or the GitLab link to download, use, and also modify and apply this code to your system, to your application. For the industrialization of the project, we chosen to focus the attention on a couple of solutions we implemented on our fuel cell system. And first, we needed to adapt a generic use stationary fuel cell for maritime application. And so we needed to implement an air filter to reduce the air salinity, and also an anti-splash casing to protect the cell from water, but still ensuring the correct airflow and air cooling of the stack. In addition, and in order to increase the flexibility of the control and to reduce weight, we removed the manufacturer control device and we integrated its control logic in our main control unit of the boat. Obviously, these solutions can be scaled to larger size applications. I want to conclude just saying that even if a simpler system would have been easier to manage and also to develop, we think that a more complex system based on both battery and hydrogen could be one of the key solutions to achieve a more sustainable mobility and a carbon neutral mobility. So thank you for
Standing ovation.
No, really, you can be proud of you. I am proud about what you have done because when I read these rules 3 or 4 years ago, I did not imagine that so quickly some team was able to catch the numbers I anticipated in my mind. And no, very, very happy that you achieved that. I'm sure there is plenty of questions. So who want to ask question?
We were too clear. No question at all.
No, I think yes, because okay, you want to win. You made a fantastic job. There is nothing to say on that. I have 2 questions. It looked like you made, let's say, a lot of analysis coming from the experience. So maybe you was a bit safe due to the time of the coronavirus. So you had 2 years to try to be ready on time. And I am a bit concerned about 2 things. What will be the next evolution to try to improve the efficiency and the amount of energy on the fuel cell? Because I guess by saving weight you can go a lot faster. And my second question will be, as you are a very smart people, why don't you use the propeller, which is more efficient in another way or with another engine?
I try to answer to the first question regarding the fuel cell. We declared 40% efficiency which is the actual efficiency of our fuel cell. And the main reason is that this fuel cell doesn't have the recirculation of the hydrogen. So you lose some hydrogen with the purging valve. And so I think the first thing to implement to increase its efficiency, perhaps up to 50%, could be this modification, the recirculation of the hydrogen. And this is pretty much. And also, we are planning to change the provider of the fuel cell, maybe to go to some more specific system for mobility, for automotive, or something that can be implemented in a more efficient way in a boat.
Yeah, you have to target 60% efficiency. And this is what we are having today in, let's say, the professional usage. That was confirmed by some of my colleagues this afternoon in the hydrogen conference. So I am sure that such a good team, you can target in between 60 to 65% efficiency on the fuel cell. And please, for the next time, all the other team, that will be also very good if you can give the details about the fuel cell, how it is working, how you manage the fuel cell, depending on that. Very happy that you have this open source, but that might be very helpful for them if they want to move through the hydrogen, because it's something very special. And so can you also answer the second question about the engine?
Yeah, from the motor, the truth is that we began the project in November more or less of 2019 with the idea of participating in 2020, so the time was really tight. So we were going for solutions that were already working, let's say, and then when everything COVID happened, and then we jumped to 2021. We went for the complicated, let's say, alternative of modifying the inverter, when going with everything custom. So, and we were already stuck with the decision of buying that kind of engine. But we sooner or later quite quickly realized that it was not the best for thermal reasons and many other things that I imagine you already have in mind. But that's...
I'm very looking forward to see your boat with a 10 kilowatt engine and a very efficient propeller, as you can speak with some of the Solar Dutch team. Congratulations.
Thank you.
Congratulations, you can put off your microphone and then have a seat. First place in energy class for you today, and then this is Sunflare solar class. You can go to the stage. I call you, please, with your applause for the Dutch team also. Now it's your tech talk, and you have 7 minutes, please, before questions.
Good afternoon. We are a Sunflare solar team. We're from the Netherlands, to be exact, Friesland, that's in the north. We've been participating here for over 5 years. This is our 6th time being here. Our team consists out of 8 members. Myself, I'm the pilot, I'm Gerlof. We have Ruud, Arjan, Hilke, Margien, Taye, Kees and Maro. We're doing this in our free time, and with the help of our sponsors, we've been very successful the last few years. We started in 2016 with building our boat. We had to make a choice because of with the design. We simulated a few different boats. We decided to buy or lean a mold from the other teams who were already participating, and we ended up with a Finnish team from Kotka. They were participating in the old T-class, which was a bit longer boat, 7 meters, and we bought the plug from them, so we were able to design our own boat, and we shortened it to 6 meters. Last year, of 2019, we made our own solar cells, and we managed to get 1500 watt peak out of the 6 square meter solar array. Our battery is around 1500 watt peaks, and we are able to sail up to 50 kilometers per hour with a 6 kilowatt electric motor. And one of their most efficient points is around 25 kilometers per hour, and I will come to that later. We use different CAD software. We gathered them over the years. One of them is SolidWorks for all the mechanical parts, and the carbon fiber things we always design it. For the electronical systems we use Altium, and they communicate with each other, so we can send the PCB designs to SolidWorks to check if they are fitted on the places they have to be. Yeah, we always design, then make the production, test and validate, and if there is something wrong, we redo the design and improve the things. For example, during the production, we had some minor issues with the maximum power point trackers, so currently we are designing a second one. I see there's some missing here. A few years ago we built the hull. It was around 400 hours man-hours. During one of the designs was also the foils, the struts, that's new parts this year. They're made of carbon fiber, but the whole drivetrain is made of aluminum, steel, and the more hard parts. We faced some problems during the production of the foils and the struts. For example, the spec sheets of the carbon fiber told us the sheet thickness should be around 0.4 millimeters per sheet, but they ended up to be a bit thicker. So the first few production parts, they were thicker. We couldn't close the molds together. We use a wet layup production method, as you can see with the foils. We put the wet laminate inside the two halves. We preheat them till a certain point so the epoxy is thinner, and then we press them together to make an even tighter and high carbon percentage. And currently, you may know there's issues with the supplies of all the products you need, all the components, and that's also one of the things we are struggling with electronics. If we choose components, we design a PCB, most of the time some of the components will not be available anymore. So now we changed our design a bit. We now first choose the components, buy them, and after that we will design the PCB because we have to be certain we have the right components. During testing, we've been flying with different people in the boat. We measured our speeds and power consumption at different RPMs. That's one of the most consistent value things the RPMs we can keep the same and check the influence of the weather. As you can see over here, the blue lines, it's at one and the same speed of motor speed, and with the wind and the waves are always influencing, so we get a line between that, and with all the curves of it, all the dots, we made a curve of the average. And you also can see the difference between the non-foiling and foiling curve, because foiling is much more efficient. After 25 kilometers per hour, the non-foiling stops because we start to foil more stable. For this year, a few years ago, we lost our drivetrain due to error in the design. We told it a few years ago, so I will not go in detail for that. But we decided to make a new drivetrain and go to the absolute maximum what's possible with the components. So we were able to have the gearbox inside with only a diameter of 35 millimeters and able to put 6 kilowatts through that. Also the hydrofoils and the hydrofoil system. You may have seen it with the races today or yesterday. It's a bit too direct for the waves here in Monaco, but it's working quite well. We are able to stay out of the waves, keep the boat dry, and for here that's one of the most important things, because salt water in the boat and on the electronics is a big issue always. And you can see here the solar MPPTs, maximum power point trackers, the version 2. It's a dual setup, and it's configuring a bit more efficient the energy from the solar panels to the battery. We have a peak efficiency around 99.5%, and by making it ourselves, we can keep the price quite low. Do we have any questions?
I think yes, there are questions from jury members first. Or in the public. Question from SBM Offshore.
Yes, thank you very much for your very interesting presentation. My question is, you started off with the remark that you fabricated your solar panels yourself. Can you elaborate a bit on that?
Yes, I can. We haven't put it in the presentation, but we bought the cells from SunPower, and we focused on decreasing the weight of the solar panels, because the available panels right now have a weight of 2.5 kilos per square meter, and our main focus is being more efficient and lighter, so we decided to make the panels by ourselves, and we managed to get only 1 kilo per square meter by removing all the extra materials. Thin glue layers, thin filament layers, and the bare cells. Any other questions?
Yes, jury members, jury chairman, questions.
Thank you and congratulations for the result of today, by the way, and all the previous year. Something which is I really amazed me on your boat compared to the other one is that you always try to do the thing simple and very efficient. And look like everyone is trying to have a stable flight with very complex solution, and you're still using the mechanical control with a sort of
with the wands.
Yes. So have you made a sort of calculation and by comparison the benefit, and could you explain why you are keeping this solution which is working? Huh?
Yeah.
I'm not saying this is not bad, but maybe you can be more efficient with let's say other sensors. So can you share with everyone where you are and in your mindset by using these tricks, let's say?
Yeah, the idea behind the wands is they measure the height before the foils, and then if there's a wave, the boat has a little bit of delay to increase its height and compensate for the waves. The reason why we're using mechanical is because it's simple. It's one of the most simple things. No electronics, no errors in control systems. And that's the easiest thing. And we are looking into the next step. It's we will go to a hybrid system, electric mechanical system, to be more in control of it all. And maybe later on we will convert it to a whole electronic system. But for now, it's taking a lot of time to perfect an electronic system, and many teams are trying it, but they all struggle with it. So,
and because you are now starting to have enough feedback and data, I guess, on your several sailing, what amount of efficiency you think you can save by replacing this, let's say, flight stability by electronics compared to this mechanic?
I guess there will be a slight efficiency increase by doing that, but also the motors, for example, controlling the foils, are also consuming energy. So it's a bit of a comparison we have to make, but for ride comfort, electronic will be better.
Understood. And last, 2 years ago, you gave the details about your powertrain that unfortunately you lose in the water. That was amazing, and I guess if I do remember correctly, it was 8 or 10 kilowatt, and now you are saying that you have just 6 kilowatt engine. Why do you choose a little less power than other competitors that are higher power? Because some of your competitors go up to 12 kilowatt, if I am not saying.
Yeah, I know Technico is trying to do 15 kilowatts, 15, so that's quite a lot. We limited our motor current to be sure that we don't break the drivetrain. If we would increase the power, the gears will break. So we're at the absolute limit, and that's why we don't choose to use higher motor powers.
Understood. So, and what might be the next evolution of your boat?
Could you repeat it?
Sorry, following the point where you are now, if you have another, I don't know, sponsor that you already have some of them, but what will be your next upgrade of your boat for the coming years?
Now, we currently are looking at the boat, and it's getting some damage, some scars from the past few years. So we are considering making a new one and putting all the things we have learned from the last few years into the new boat, and also maybe new electronics, the drivetrain is still okay, but the foils could be improved, and what I just told, maybe a new foiling system, more electronic regulated. So we will have to see what we can come up with, and we have to keep in our mind we're doing this in our free time, and we were always students, and we now most of us are graduated and are working with companies, so we have less time, and we have to manage that. And if we try something new and it doesn't work, or we can't get it in time, we have to be able to put a step back and use the old system. So that's something we have to use.
And last question that I think might be might be good for all the jury member. Maybe it was you or another team, but I think it was you 2 years ago. Do you know the exactly efficiency of your drivetrain with this propeller and this weight and falling system?
Yeah, quite. If I, for example, for the efficiency from the drivetrain, our motor has a peak efficiency of 93%. Also, we lose some in the controller and the batteries, but if it's pure mechanically, the shafts, the gearing of the bearings have some energy consumption of the friction, and the gearing in the 90-degree reduction. Yeah, lose 2 or 3%, and the propellers have an efficiency around 80 to 85, theoretically, but I haven't tested it to be sure. So we're losing a bit of energy there, but it's quite high. And for a conventional ship propeller, for example, it's 65-70% maximum.
Yeah.
So, yeah.
Perfect. We have a question down there.
I have a question about the shaft. What is?
Please just your microphone on the mouse.
Yeah. Yes, I have a question about the shaft. What is it made of, and what are the bearings material? The vertical shaft.
Yeah, the vertical shaft?
Yes.
What type of bearings, or what was the question?
The vertical shaft that provides the power to the propellers.
Yes.
What is it made of?
It's made of steel, hardened steel. I'm not sure. I'm just thinking, because the shaft is only 8 millimeters, most of the raw material is bigger, so we decided to use a linear bearing of, how do you say it? Linear. Do you know the shafts that are used in the 3D printers? They're made of steel. It's hardened and it's with a tight fitting. It's, for example, 8 millimeters with an 8/6 fitting. So the bearings are nice and quite tight around it. We bought it in a whole thing, only 8 millimeters shaft. It's, I guess it's C51 material. I'm not sure.
Thank you.
Yeah.
Close. For Sunflare, the fastest today again. Is there another question? Thanks, jury members. Thanks, everybody, because at the end of the Tech Talks for today. Thanks, everybody, and see you tomorrow morning for the slalom race and the championship race in the afternoon. Thanks again. And if you want to participate to the challenge at the simulator video game, you can ask Pauline. And there is a surprise for the contestants. Surprise from YCM. concours ce soir, adressez-vous à Pauline, juste ici, avec une surprise pour le vainqueur offerte par le Yacht Club de Monaco. Challenge for the simulator video game now.